Let's solve some problems. Okay, let's look at the first one. Show that the spheres are orthogonal. Spheres are, let's say, S1 x square plus y square plus z square plus 6y plus 2z plus 8 equal to 0. And the second one is x square plus y square plus z square plus 6x plus 8y plus 4z plus 20 equal to 0. Now, pretty straightforward condition. The condition being 2 u1 u2 plus 2 v1 v2 plus 2 w1 w2 is equal to d1 plus. If the left hand side and right hand side are equal, then they are orthogonal. So here S1 2 u1 x equal to, it's not there at all, so 0. So which means u1 equal to 0. Now 2 v1 y is equal to 6y, y 2 3. So which means v1 equal to 3. And similarly 2 w1 z is equal to 2z. So z gone, 2 gone, that means w1 is equal to 1. So we have got u1, v1 and w1. Similarly, in case of S2, let's see, 2u2x is equal to 6x. x2 3. So u2 equal to 2v2y is equal to 8y. So y gone to 4. So v2 is equal to 4. Similarly, 2w2z is equal to 4z. So z2 2s. So w2 equal to. So we have got u1 v1 w1 u2 v2 w2. So now it's just a question of substituting the values. In any by the way, d1 is equal to 8 and d2 is equal to 20. So we do the substitution. 2 times u1 times u2 plus 2 times v1 times v2 plus 2 times w1 times w2 is equal to d1 plus d2. So this becomes 0 plus 3 to 6. 6 4 is 24 plus 4 is equal to 28. And this is 28 equal to 28. Therefore, the spheres are orthogonal. Find the value of k such that the spheres are orthogonal. And the spheres are again S1 x square plus y square plus z square plus 7x plus ky. This is what we have to find. Minus 5z plus 12 equal to 0. And S2 is x square plus y square plus z square minus 4x plus 6y plus 4 equal to 0. So here z is not there. So as usual, let's figure out u, v, w of both these spheres. So in case of S1, 2u1x is equal to 7x. x gone, so u1 is equal to 7 by 2. 2v1y is equal to ky. So y gone, so v1 is equal to k by 2. Similarly, 2w1z is equal to minus 5z. So z gone, so w1 is equal to minus 5 by 2. Let's do it for the second sphere. So 2u2x is equal to minus 4x, x gone, 2 2's. So u2 is equal to minus 2. 2w, no, not w, 2 V2y is equal to 6y. So V2 is equal to 3. And Z is not there. So which means 0. So W2 is equal to 0. Now we know S1 and S2 are orthogonal. Therefore, 2u1 u2 plus 2u, no, not u, v1 v2 plus 2 w1 w2 is equal to d1 plus d2. Okay, let's do this. 2 times u1 is 7 by 2 times minus 2 plus 2 times k by 2 times 3 plus, and w2 is 0, the whole thing is 0. And d1 d2 is what? D1 is 12 and 4. So 12 plus 4. So which implies 2 cancels, 2 cancels. So minus 14 plus 3k is equal to 16, which implies uh, 3k is equal to 16 plus 14, 30, which implies k is equal to 10. So only when the k is 10, only in that case S1 and S2 will be orthogonal. Okay, let's do the third problem. Find the equation of the sphere which touches the plane 3x plus 2y minus z plus 2 equal to 0 at the point, let's say P 1 comma minus 2 comma 1, and is also orthogonal to sphere x square plus y square plus z square minus 4x plus 6y plus 4 equal to 0. So here we have to figure out the sphere which touches this plane, right? Which means that this plane is the tangent plane at this particular point. And the second condition is that it is also orthogonal to this sphere. So let's proceed. Now let's say the required sphere is given by x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus b equal to 0. Okay. Now, equation of the tangent plane. Equation of the tangent plane is given by what? At a particular point, that is at 1 minus 2 comma 1 is given by, remember, x1. Here x1 is this. So 1x minus 2y plus 1z. Then you substitute the value of x. So 2u, substitute x by x plus 1 by 2, x plus x1 by 2. This is x1, y1 and z1. Plus 2y minus 2 by 2 plus 2 times, and v is there, w times z plus z1 by 2. So z plus 1 by 2 plus d equal to 0. Let's simplify this. X minus 2y plus z. This 2 and 2 cancels. So plus 2, no 2 here. Ux plus u plus, again 2 and 2 cancels. y v minus 2v, again 2 cancels, plus 2z plus w plus d equal to 0. Okay, let's take it further a little bit. X minus 2, no, we have x, we also have x here. So let's take x common out. So u plus 1 x, right, plus v. Now we have to look at y. So y is here and the other y is here. So v minus 2 y plus w plus 1 z, and then rest all whatever is left out. That is u minus 2v plus w plus is equal to 0. This is the equation of the tangent, right, to this sphere at this particular point. Okay, but remember the tangent is given. So tangent is given as 3x plus 2y minus z plus 2 equal to 0. So that means this and this, they are same. So therefore, corresponding coefficients are proportional. Therefore, u plus 1 by 3 equal to v minus 2 by 2 is equal to w plus 1 by minus 1 is equal to u minus 2v plus w plus d divided by 2. Okay, so this is coming from here and this 2 is coming from here. Okay, so now let us say that this is equal to lambda. So u plus 1 by 3 equal to lambda, which implies u is equal to 3 lambda minus 1. V minus 2 by 2 is equal to lambda, which implies v is equal to 2 lambda plus 2. And similarly, w plus 1 by minus 1 equal to lambda implies w is equal to minus lambda minus 1. Now, let's do the substitutions in the third set. That is u minus 2v plus w plus d is equal to by 2 is equal to lambda. This can be written as u minus 2v plus w plus d is equal to 2 lambda. Now let's do the substitutions. U is 3 lambda minus 1. So 3 lambda minus 1 minus 2 times 2 lambda plus 2 plus minus lambda minus 1. So this plus is not required. Plus d 2 lambda, which is equal to 3 lambda minus 1 minus 4 lambda minus 4 minus lambda minus 1 plus 3 minus 2 lambda equal to 0. So lambda, 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 lambda. So 3 minus 4 minus 1 minus 1 minus 1 minus 2 minus 2 minus 2 minus 4. So this is minus 4 lambda. Then we have minus 1 minus 4 minus 5 minus 6. So minus 6 plus d equal to 0. So which means d is equal to 4 lambda minus 6. So d also we have got it in terms of lambda. So we have reached this stage. Now remember there is another condition that the required sphere cuts another sphere orthogonally. Right? So it is given that the required sphere cuts orthogonally the sphere x square plus y square plus z square minus 4x plus 6y plus 4 equal to 0. So again, let's figure out the orthogonality. No, we don't have to figure out. It's already given it is orthogonal. So we use the condition for orthogonality. So 2u1, let's say u1 is this from this sphere, plus 2v1 plus 2w1 is equal to d1 plus d, or let's say d plus d. Okay, so which means now we have to figure out the u1, v1 and w1. So 2u1x is equal to minus 4x. So u1 is equal to minus 2. 2v1y is equal to 6y. So v1 is equal to 3. And w1 equal to 0 because it is not there. And d1 is equal to 4. So now let's do the substitutions. 2 u is what? Remember, u is, we have already, u is 3 lambda minus 1. Right? So 2 3 lambda minus 1 plus, no, u1. So minus 2. Or let's do one thing. Let's take it step by step. 2u u1, that is minus 2, plus 2v v1. v1 is 3, plus 2 w w1, that is 0, is equal to 4, or d plus 4. d plus 4. d1 plus d2. So this becomes minus 4u plus 6v plus 0 is equal to d plus 4. This 0 we don't need to. Now let's take common out. Do we need to? Let's bring 4 to this side. Or let's leave it as it is. Now let's do the substitution for uv. U is 3 lambda minus 1. And v is equal to 2 lambda plus 2. So therefore, minus 4 times 3 lambda minus 1 plus 6 times 2 lambda plus 2 is equal to d plus 4, which implies minus 12 lambda plus 4 plus 12 lambda plus 12 is equal to d plus 4, which is equal to this, and this gets cancelled. We are left with 16 is equal to d plus 4. So d is equal to 16 minus 4, that is 12. Now this 12, let's substitute in this equation. D is equal to 4 lambda minus 6. 4 lambda, this should be plus minus, we take it to that side, minus 6 also we take. It should be 4 lambda minus 6. Sorry, plus 6. So D is equal to 4 lambda plus 6. Now, D, we have just evaluated it as 12. So 12 is equal to 4 lambda plus 6. So which means 4 lambda is equal to 12 minus 6, 6. Lambda is equal to 3 by k. So at last we have got lambda. Now remember, we had assumed that the required equation is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So u, v and w we require. D we already know is 12. Oh, sorry. D is 12. So now u is equal to what? We have already said this is 3 lambda minus 1. But lambda we know is 3 by 2. So 3 by 2 minus 1, which is 9 by 2 minus 1, which is 9 minus 2, 7 by 2. V is equal to, we know is 2 lambda minus 2, which is 2 times 3 by 2 minus 2, which is 2 cancel, 3 minus 2 is 1. And W is equal to minus lambda minus 1, which is 3 by 2 minus 1, which is minus 5 by 2. So now substituting it, we get x square plus y square plus z square plus 2 minus 5 by, no, not 5, 7 by 2 times 7 by 2 x plus 2 times 1 y plus 2 times minus 5 by 2 z plus 12 is equal to 0. So 2 and 2 cancels, 2 and 2 cancels. So therefore, this equation of the sphere is x square plus y square plus z square plus 7x plus 2y minus 5z plus 12 equal to 0. That is the required sphere. Now let's look at the next one. Find the angle of intersection of the spheres S1 and S2, where S1 is equal to x square plus y square plus z square minus 2x minus 4y minus 6z plus 10 equal to 0, and S2 is equal to x square plus y square plus z square minus 6x minus 2y minus 2z plus 2 equal to 0. So we have to find the angle of intersection of the spheres. Now, as usual, S1, let's figure out U1, V1, W1. 2u1x is equal to minus 2x. So u1 is equal to minus 1. 2v1 y is equal to minus 4y. So y 2, 2. So v1 is equal to minus 2. w1z is equal to minus 6z. So so w1 is equal to minus 3. So minus 1 minus 2 minus 3. That means the center of S1 is equal to 1, 2, comma. Now let's take S2. S2 is again 2 u2x is equal to minus 6x. X 2 3's. So u2 is equal to minus 3. Then 2v2y is equal to minus 2y. So y 2, 2. So v2 is equal to minus 1. 2w2z is equal to minus 2z. So again, w2 is equal to minus 1. So center of S2 is equal to minus u, minus v, and minus z. 3, 1. Let us say this is equal to C2 and this is equal to C1, center 1. Okay. Now, what will be the radius of the first sphere, R1? That would be u square, where is u, v, w, 1, 2, 3. So 1 square plus 2 square plus 3 square minus d. D is what? So minus 10, which is equal to square root of 1 plus 4 plus 9 minus 10. So 9 plus 1, 10 minus 10 is 0. So square root of 4, which is 2. Similarly, R2 is equal to 3 square plus 1 square plus 1 square minus, and d is, which is equal to 9 plus 1 plus 1 minus 2. So 2 gets cancelled. And square root of 9, which is, so we have got the center, we have got the radius. Now we have to figure out the theta, which is, let's say, the angle between spheres. And for this, remember, we have the two sides. Right? We have the two sides and we have to figure out the angle. So for this, we will be using the cosine rule from trigonometry. So c square is equal to a square plus b square minus 2ab cos. Okay. So cos theta would be equal to, if we do the rearrangement, let's say minus cos theta. This a square b square will come to this side. So c square minus a square minus b square divided by 2AB will come down, and if we take this plus, this becomes minus, this becomes plus, this becomes plus. So which means cos theta is equal to a square plus b square minus c square by 2a. Okay. Now here in this case, in our case, cos theta would be equal to what? R1 square plus R2 square, and this is the, let's say, the hypotenuse. So this will be your C1 C2 square. C is nothing but C1 C2 divided by 2R1 R2. Okay, so first let's figure out C1 C2 square. This will be equal to, okay, since we are having the square on the other side, we don't have to put a square root here. So this would be 3 minus 1 square plus 1 minus 2 square plus 1 minus 3 square. This will become 2 square minus plus 1 minus 1 square plus 4. That is 2 square. So this will be 4 plus 1 plus, which is equal to 9. Remember, this is C1 C2 square. So if we take the square root on both the sides, C1 C2 would be equal to, okay. So now let's do the substitutions. Therefore, cos theta is equal to R1 square. So R1 is how much? R1 is 2, R2 is 3. So 2 square plus 3 square minus C1 C2 square is 9 divided by 2 times 3, which is equal to 4 plus 9 minus 9 by 2, 2 4 is 12. So 9 cancels. 4 by 12. So 4 by 12 is 1 by 3. So cos theta is equal to 1 by 3. So that means theta is equal to cos inverse of 1 by 3. That is the angle between the two spheres. That is orthogonal spheres. That's it. Bye.